In this final example, we have the selection sort. Remember that this one is more efficient than the bubble sort because the result of each iteration through our array is that we have moved two values. So we have moved the lower value towards the beginning, which is what we want, and we have moved a higher value away, which is also the result that we want. So we'll click through to selection sort and point out a couple of the things here. I have used exactly the same display array function from the previous example, so there are no changes there. Again, that is the value of modular programming. Is, my data set is different. Whoop-de-doo. it's going to work exactly the same here as we have in our display array, so we'll save the time not going through that. And this time around we have our selection sort. Now, here is my set of values. We can only run this one time because the resultant will be that our numbers will go in order. So hopefully this is a one-take shot, because otherwise these are going to be in ascending order, and that's not what we want. But the way we can test that is 112 is here in element number 0, and just off the top of my head I see a 5 right over here, which is not element 0, so this does need to be sorted. So what we'll see is the exact same thing through main here. We are going to call display array, we're going to call sort array, and then selection sort array, and then we're going to call display array again. So really here, starting on line 41, this is where the new wrinkle in our code comes from. So first and foremost, inside of our selection sort function here, we are going to need an integer. We're going to call it seek. So that is the position, the element number of the array that we are currently going to search for. So that's going to be used essentially like our counter would be. We're going to have a minimum count, min count. That is the location, so the element number of the smallest value. We are going to have a minimum value that is going to be the value of the lowest value. I know. So we've got a nested for loop that we're going to need for this. So the outside loop is going to perform the swap, right? So that's actually going to, take min count, so our element number, and min value, and actually do the swap there. And that's going to be based on seek, which is the element of our array that we're going through. So that is taken care of right here with min count equals seek, and min value is array at seek. So what we're saying is when we start at 0, we're going to take that value as the lowest, and we're going to search for anything else that's less than that. So here in our inner loop, this is where, and I wanted to put this in text here so that you could see what we were doing. The inner loop searches through the array, starting at array seek, so 0 and moving up, and it searches for the smallest value. When it has found a value that is smaller than the one that we have in seek, it switches their value. And then we go back up to the top, and we can move one more element over and do the exact same thing over and over and over again. The benefit, again, to a selection sort is it does not run anywhere near as many times as n-1 because we're doing 2 swaps at a time. It's a logarithmic value for that. I'm not here for the calculus, neither are you. So then here, inside, this is where we do the swap. So we're saying whatever the element is that we have found a lower value at, we would swap that. So then the value comes over here to seek, and the temporary value of seek goes over to wherever we found the next lowest value at. Let's run it and see. So if we go ahead and run this, here are, I did lie actually to you beforehand, just because this was really messy when I ran this. What I wanted to do was format it a little bit. So I did add this if-else statement inside of display because I know some of you still really hate using the modulus operator. I built it in here just to make you vomit a little bit and see how great it is. So I said if count modulo 5 equals 0. So what we're saying is if count is divisible by 5 with no remainder, do this. See out a new line. So that's why we've got 4 values here and then a new line. That's it. I thought it looked cleaner this way. I tested it with 6. I just didn't like the way it looked. So here we go. 109, 102, 132, 184. We can tell that that is not in ascending order. But here we are, 14, 20, 21, 25. This now is in ascending order. So we have accomplished that with the selection sort, which uses essentially a 2-element swap to get the job done. Remember, it is not as inefficient as n-1 for the simple bubble sort. It is more efficient than the bubble sort modified that you have seen. But still, this operation with hundreds of millions or billions of data elements in the set that we are looking at might very well take a long time. So that's something that you should be aware of.